In the last video, we have described the condition number with respect to matrix norm and how we can define or describe the system of equation, whether it's a ill-conditioned system of equation or well-conditioned system of equation. Now again, I am going to emphasize on the definition of the condition number. Here, the condition number of a matrix A of the system of equation Ax equal to B. A is the coefficient matrix, X is the solution vector, and B is the right hand side of the equation. B vector represents the right hand side of the equation. And the condition number is described in terms of matrix norm as condition A, norm of A multiplied by norm of A inverse. And this norm may be absolute norm, or we can call it as column norm, or Euclidean norm, or infinity norm is also said as row norm. Okay. Now, but most commonly we always use infinity norm. Okay. So, in terms of infinity norm, the condition number is represented as norm of A infinity multiplied by norm of A inverse infinity. Okay. Now, larger the value of the condition number, if it is a very, very large number, then the system of equation is said to be ill-conditioned. So, now I am going to give you an example. Let us give an example. Ax equal to B is represented by this equation. Okay. A is 1, 1, 1, 1.001, xy, x is the solution vector, 2, 2. And if I solve this equation, you get the solution as x equal to 2, y equal to 0. Now, if I change B, first of all, let us say whether it is ill condition or well condition. So, B changes to 2 and 2.001. So, new system of equation will be like this. And when I solve this equation, new equation, then I get the solution as x equal to 1 and y equal to 2. Okay. Now, if I compare the equation, if I compare it with the original solution, we conclude that the small changes in B leads to a large changes in the solution vector x. Why? X from 2 to 1, original was 2, then it changes to 1. Similarly, y changes from 0 to 1. So, we can say that this system of equation is ill conditioned. Now, let us see how we can use the conditioning number to define whether it is an ill condition or well condition. Now, again use what is the matrix, A matrix in that equation, 1, 1, 1, 1.001. Now, what is the norm, infinity norm of A? Infinity norm of A is maximum 1 plus 1, comma 1 plus 1.001. It is the sum of row values, absolute value of the rows, absolute value of the elements of the row. Okay. So, maximum 1 plus 1, 2, comma 2.001. So, the value is 2.001. Okay. Now, what is your A inverse? It is very easy to find out A inverse. Please check and do. A inverse for this matrix is found to be 1001 minus 1000 minus 1000 and 1000. So, now let us find the norm of infinity norm of A inverse. Infinity norm of A inverse is maximum, this value 1001 plus absolute value of minus 1000, comma minus 1000 elements of this row plus 1000. So, maximum between 2001 and 2000. So, we get the norm as 2001. Now, what is the product? Condition number is the product of norm of A is 2.001 and A inverse. So, 2.001 into 2001, and what we have got? We have got 4004.001. So, this is a very, very condition number is very large. So, the system of equation is ill conditioned. Let me give you another example which is actually well conditioned. We have found this, we have done this problem and found that this is a well conditioned system of equation. 1, 2, 2, 3, xy, 4, 7. So, it is already defined, we have already proved that this is a well conditioned system of equation. Now, let us see whether we can prove that using the matrix norm. Okay. So, A is this. So, infinity norm is again 1 plus 2, comma 2 plus 3, maximum between these two, 5. Similarly, A inverse is, you can easily find out the A inverse. Infinity norm inverse, norm of infinity norm of A inverse is again 3 plus 2, absolute value of minus 3, 3 plus 2, 2 plus 1. So, 5 comma 3, this is 5. So, what is condition number? Condition number is the product of these two values, 5 into 5 equal to 25. So, which is a small value? So, the system of equation is well conditioned. So, now you can easily find out any system of equation, whether it is a very large system of equation, you can get your A value, you can inverse it, find the norm of A, find the norm of A inverse, product it, multiply it, and if it is a very, very small number, it is a well-conditioned system of equation, and if it is a large number, large value like 10 to the power 3, 10 to the power 4, 10 to the power 2, something like that, so then it is a ill-conditioned system of equation. I hope you have understood this conditioning of a system of equation. Thank you very much.